Is Mr. Ng going over the pre-calc chapter 4B test taken on April 6, 2018, version B. Question number 1, find the amplitude of y equals -5 cosine 3x minus pi. A couple of things you should notice. If you write out your letters, you'll have a cosine b x minus c. And this problem says the amplitude, so we're just focusing on the a value. So your a value is -5, but that's not choice E. Amplitude is the absolute value of a, which tells us the answer is 5. If you ever do need to factor out and find the b value, you have some values that you can factor out and you're not quite sure, so here's your hint. It tells you the 3, so pull out that 3. And the question is, what goes in this box? 3 times x is 3x, 3 times blank equals pi. So if you just make the unknown a variable, or I just put a box, so 3 times this box equals pi. 3 times the box equals pi, so if I divide by 3, that means that the box is equal to pi over 3. And I'll give you the c value if you need it. Here's an example of a student who got the problem incorrect. They just circled -5 because they saw that. They should have labeled your A, B, C's, and D's. Question number 2 says solve y equals arcsine 1/2. So essentially in this problem, the arcsine is the same thing as the inverse of sine. And it tells us we need to solve for y. Well, in order to do that, I can switch it. So if you switch it, you show the arrows. These will switch places, so now I have a 1/2 and I have a y, but you're taking off the inverse sign. It's like turning off a light switch. So where is sine at an angle where it's positive 1/2? Well, sine is positive in 2 locations, quadrants 1 and 2. Notice how at 1/2, I'm looking for the second order pair, so here's my counting 1, 2, 3, then there's a 1, so sine is 1/2 here. My 2 locations there would be pi over 6, and then over here, so that'd be at 1/2, so that'd be 1, 2, 3, 4, 5 pi over 6. Sine is 1/2. So here are my 2 answers, but to restrict the domain for sine, for the inverse of sine is -pi over 2 to pi over 2. You should have had that on your formula sheet or memorized it. Let me show you guys version C. Version C, I actually just gave them the chart, so if you had version B and A, you had had that on your own notes. So I need something in between -pi over 2 and pi over 2, and the only answer that actually meets that is pi over 6. So the answer is D. So you have to look at the restricted domain. This is interesting. I wanted to show you student work. Correct answer. But when they took the inverse, they found the 2 sides, and they were trying to find the third side, and they got right equal 3, and then so they have the other side lengths, but you don't need any other trig function. So it's interesting that this student got the correct answer, but even though it's multiple choice, I'm not looking for your work. This work is incorrect. Question number 3, given the function y equals 3 minus 2 cosine 4x minus 5, determine the period and the phase shift. So here I wrote down the problem, and the next thing I'm going to do is that I recognize that to get a b value, in our class, we've been learning that you have to factor out that b value. So what's your hint? Your hint is that you can factor out a 4. And so you're thinking to yourself, 4 times something equals 4x. That's going to be 4 times x gives you 4x. 4 times something is going to give you a -5. Well, the answer is 4 times 5/4. Because you put this over 1, your 4's will cancel and you're equal to 5. So I write the letters. A value is in front of the trig function. B value is the number or value that was factored in front of the parentheses. C value is inside the parentheses, and the D value is the constant. Sometimes it's way over here. So my A value is -2, B value is 4. My C value is 5/4 positive. Remember, notice how in the formula, same, different. And the D value is 3, which I don't need because we're asking for the period. So the period of cosine is 2 pi over b. My b value is 4. Simplify, and you get a period of pi over 2. So that'll eliminate choices C and D. Then over here, my C value is a positive 5/4. 5/4 means you're going to the right 5/4. So that would be choice B. I remember I had a silly phrase, add to x, go west or left. So here in the original problem, you're not adding to x, you're not going left, you're going the opposite direction, so you're going to go right. All right, the student recognized that you can eliminate C and D based off the period, but didn't know how to factor that. So pay attention to a factor because they're essentially guessing, right, left or right. They just need my special phrase. Question number 4, what is the value of tangent arc cosine radical 2 over 2? So the first thing I do in the problem is that I'm going to put a box around the parentheses here so that I call it alpha. Alpha is equal to arc cosine radical 2 over 2. And the reason why I do that is based off of cosine, I can find something about the angle and the other side lengths, and then from there I can find tangent. So if I take the inverse, that's what arc is, just known for inverse, I switch them, take out the word arc. Then I'm looking for cosine where it's a positive radical 2 over 2. All students take calculus, so here in these two quadrants, and then my two angles, well, the two angles tell us about the side length, so the adjacent and the hypotenuse. So radical 2 and the hypotenuse is a positive 2. And then when you use Pythagorean theorem, you'll find that the other side length is radical 2 over 2. Or you should have just recognized that a radical 2 over 2 is a 45-degree angle, so the special right triangle is leg, and then radical 2. So these are the same, isosceles right triangle. From there, you're just finding tangent. So tangent is the opposite over the adjacent, so that would be radical 2 over 2, which is essentially 1. And that's my answer. Student guessing here. I guess they knew, hopefully they knew that radical 2 over 2 is a 45, and then what is tangent out of 45, which is just R1. Alright, so the can was either 5 points correct or 1 point wrong. Here's my solutions. It's a 4x4, and the front side was out of 45 points. Backside. On the free response question, this was out of 25 points, and normally I grade it out of 4, so that basically means that if I do a proportions here, each point I normally award is 6.25, so I just use that as a factor. So if you try the problem, got it clearly wrong, 6.25. If you took the inverse in this problem, so you're just taking a square around this value. And then basically what you're trying to find here is sine. So tangent, whatever variable did, I did theta. Theta equals the inverse of tangent of 1/2. So if I take the inverse or switch them, I take off that inverse sign and then I get 1/2 equals tangent theta. Tangent is positive in quadrants all students take, so quadrants 1 and 3, but it's just, of the two quadrants, pick the easiest one, which is quadrant 1. Tangent is opposite over the adjacent, so from theta, opposite side, that's 1, adjacent, then you do the Pythagorean theorem. I labeled these A and B, C that I'm trying to find. In your Pythagorean theorem, make sure you're using your substitutions. 2 squared is 4, 1 squared is 1, add those together is 5, take the square root, plus or minus radical 5, but remember your hypotenuse is a length, so it would be a positive radical 5. From there, I just do tangent, which is the opposite over the hypotenuse. That'll be 1 over radical 5, and then you rationalize by taking the denominator and multiplying both numerator and denominator, multiply across, you'll get radical 5 over 5. If you took the inverse, you got tangent of theta equals 1/2. I gave you 2 points, or essentially 12.5 of the 25. If you were able to use the Pythagorean theorem and you got to radical 5, you got 18.75. The most common mistake was S5, not simplifying, so most likely if you got a 3, you got 1 over radical 5. Here's a problem. Student work that received full credit. Looks good. Box. The student had an idea of where to put 1 and 2, but didn't realize that sine is the opposite of the hypotenuse, so you need the next side. Here, I don't know why I gave the student full credit. They should have gotten partial credit because this is not simplified. Here, the student did a couple of things. They knew to take the inverse, but remember, when you take the inverse, you have to take off that sign, and then they didn't know how to use that tangent one's opposite of the adjacent. They have that. You just have to do some substitution of values. Could have put an alpha down there. Graph the following trig function over one period. Be sure to include table values and label your axis clearly. Here are the 5 ways that you got your 5 points and then how they're equivalent. So finding the period, 1 point for finding the x values and x-intercepts, 1 point for the table, 1 point for the graph accuracy, and graph shape. For example, if I give you tangent and you graphed sine, then that would take it off. Because this is out of 29, you do proportions and each one is worth 5.8 points. This does not mean if you found the period you got 29 points. I just did a scale of if you got it like something correct, I'm going to give you 11.6, or you missed one thing, I'm going to go 23.2. So these are not equivalent in this direction. So here you have tangent. I'm going to write the letters y equals a tangent x minus c, and notice how I didn't have to write the letter b nor the letter d because there is no constant and I don't have to factor anything out. A value is -2, b value is equal to 1, and then your c value here is pi over 2. Common mistakes include the negative. With a positive c value, pi over 2, you're going to go right, so your phase shift is right pi over 2. And in this problem, your b value is equal to 1. So in the tangent period is pi over b, so pi over 1. So we're going to finish the graph by pi, a length of pi. And you can kind of see that in my finished product. Going here from pi to 2 pi, this is a whole tangent. From 0 to pi, there's a 1 whole tangent. Well, what do you do when there's a phase shift? Well, originally we started from 0 to pi. And you're going to include everything to the right of the trig function. All of this, put it between here. And then you're just going to solve. So to get rid of this, you're going to add pi over 2 to both of these. This becomes pi over 1, or I need a common denominator. So 2 pi over 2, and then add that. So that's 1 pi plus 2. That gives me 3 pi over 2. So my interval is pi over 2 to 3 pi over 2. So pi over 2 to 3 pi over 2. From there, I just need to find my x values. So it's hard to do 1 plus 3. You can. 1 plus 3 is 4, and then divided by 2. My midpoint is 2 pi over 2. And then how do you get a midpoint between pi over 2 and 2 pi over 2? Well, you're going to have to double this. So I did 2 pi over 4 and 4 pi over 4, and then you realize you have 2 plus 4 is 6, divided by 2 is 3, so you're counting 2, 3, 4, 5, 6, 7. And there's my 5x values. And I circled the ones in red here that are the simplified ones. Pi over 2, 3 pi over 4 pi, 5 pi over 4, and 3 pi over 2. So I'm moving on to the table now. In the table, I'm going to start the furthest right, so it's telling me with the x values, which we've just written down, you're going to subtract pi over 2 from here. Subtract pi over 2. If I subtract pi over 2 here, I'll get 3 pi over 4 minus pi over 2 gives me pi over 4. Pi, subtract pi over 2 is pi over 2. Remember, pi over 2 is equivalent to 2 pi over 4, so you can subtract 2 pi over 4 from here, and you get 3 pi over 4, subtract, in this case, this is 3 pi over 2, subtract by pi over 2 gives me 2 pi over 2, which is pi. And then here, you should recognize this is the golden rule for tangent. Where do I get these values from? Just come over here. Tangent is y over x, and then at pi over 2, y over x is 1 divided by 0. Sorry. At tangent at 0, I was thinking that's undefined. Tangent at 0 is y over x, so 0 divided by 1 is 0. At pi over 4, this is the same expression over itself, that equals 1. At pi over 2, 1 divided by 0 is undefined. 3 pi over 4 is just the same expression over itself, but positive divided by negative is negative 1. And 3 pi over 2, that would be 0 divided by negative 1 is 0. And then after that, all you have to do is multiply your values by negative 2. Multiply it by negative 2. Negative 2 times undefined is undefined, positive 2, and 0. Then I can just go ahead and graph these. At pi over 2, I have 0. 3 pi over 4, negative 2. At pi, it's undefined, so I'm going to draw the asymptote right there in pink. 5 pi over 4, I have positive 2. And at 3 pi over 2 is 0. So essentially your graph's kind of like inside this little box here. And you don't need to. If you had that, you would have gotten full credit. But if you ever want to expand it, my hint for tangent is there's like these 3 dots, these 3 linear dots. 1, 2, 3. See it? Same thing with cotangent. So this is our snake for tangent. And so you know that you just expand your graph. Well, if I already have the denominators of 4. So when you're expanding it, then, you know, just here's my original 5 dots in red. 1, 2, 3, 4, 5. And you'll notice that you have the first 2 dots, 1, 2, 4, cotangent, just add 2 more dots, 1, 2, and then you have your 3 dots, 1, 2, 3, and then you see the asymptotes for every 5th point, 1, 2, 3, 5th point, and then 1, 2, 3, 4, 5. And again, you can just take that point and substitute it in, and then you'll recognize it as an asymptote. So that's I was at a 54. Remember, let's say all of this is correct and your period is wrong, then I marked you down to 23.2. You'll see the checks and X's as a combination of right and wrong. And then this whole version was out of 89. So please score, add up 2 scores, and subtract any of those, and you get your final score. I love math.